Hey guys, today we're going to be finding the exact or maximum number of turning points for a function, okay? And so I'm going to do an example one here, and then as I go I will explain what's happening, okay? It's probably best if I just jump in, show you one, and then explain what's happening. So we're going to start off with the function f of x equals x times x plus 4 times x minus 2. Okay, so that's the function that we're given. So I need to find the exact or maximum number of turning points for the function. Okay, and then I'm also going to label the number as exact or maximum. So what I have to do is I need to find what is n. Okay, n is going to be the degree of this function. Okay, so I'm going to do FOIL here and then multiply by x. So first I'll do the FOIL, so that's x squared, and then outer minus 2x inner plus 4x last minus 8. I'm going to simplify this while multiplying everything by x squared, so I have x to the third, okay, and then plus 2x squared minus 8x. All right, so now I can see what n is. N is the highest exponent here, so n is 3. Okay, so n is 3, and the way that you find the number of turning points is to take n minus 1. So the number of turning points is either maximum or exactly 2. Okay, so I need to determine, is this exact or is this a maximum? So is it exact or is it a maximum of 2? All right, so the way I do that is if a polynomial function, okay, if the degree n, okay, so if n is equal to the number of distinct real zeros, okay, so if n is equal to the number of distinct, there's a C in distinct, distinct real zeros, then it's exact. Okay, okay, if not, it's just a maximum. All right, so if n is equal to the number of distinct real zeros, it's exact. So what do I mean by that? I have to look at this original function, okay, and see if there are the same number of zeros. So if n is equal to the number of zeros, which is how many times it crosses the x-axis, right? So I'm going to set each of these pieces equal to 0. X equals 0, x plus 4 equals 0, and x minus 2 equals 0. Well, there's 1. Minus 4, minus 4. So x is negative 4. Add 2, x is 2. So there's 2 zeros, 3 distinct zeros. There's a 0 at 0, there's a 0 at negative 4, and there's a 0 at 2. So the answer to this question is how many turning points are there? There are exactly 2. because there are three, or that's n is the degree of this function, and there are three distinct zeros. Right here, 0, -4, and 2.